Hello everyone, welcome. This is our first almost annual right now research series meeting. Thank you for joining us today. And I'm going to talk shortly what's the purpose of that research and networking series. And we call it Building Connection for Collaboration Across Campus for AI and Interdisciplinary Research. So what we are trying to do it, if you attended in this meeting before, we are trying to create a collaborative environment and platform highlighting the impressive work has been done by Elan faculty members. We hope to foster discussions across campus so that people are going to pollinate different ideas, cross-pollinate different ideas to advance and discover some new stuff related to AI and in their discipline. And we know that AI promises some benefits, also comes with challenges and threats, and we need some evidence and approach that's going to enable us to make informed decisions. So goals of this network: encourage interdisciplinary collaborations, share AI-related research and applications, create an opportunity for people to show their great work, and let work shines, all of our work shines. And last year, we established it, and it kind of hit the goals that we set it for. We just hosted more than 85 people, get participant and audience, more than 85 people throughout semesters. And also, we established a team. During the summer, people start working on certain grant projects. And then a couple of grants, we targeted NSF grant, NEH grants, and so on and so forth. And still we are building some teams to target some additional grants, and we are asking how we can just do with our partners on campus. And this semester we are targeting 3 major grants at the institutional level. I'm going to send you the email if you're interested in. Please join this grant team so that we can pursue these grants together. Apart from that, last year we organized AI Pedagogy Challenge, and we have indeed our winners in the room, Israel Balderas. So this year, we are partnering with CAA. I'm going to send an email soon. There is 13 institutions. And what are we going to do? If you're familiar with the Coastal Atlantic Associations, there's a William & Mary's, Hofstra, Drexel, Northeastern, Stony Brook, and so on and so forth. We agreed that we are going to send our AI champions, AI leaders, to compete against how they are developing using this technology in their classroom, show them work they are doing. We have a few categories. One of them is in AI teaching, AI research, and if I'm not wrong, one of them AI staff and productivity gain for the staff members. So we are going to pick 3 or 6 representatives from Elan going to go to Stony Brook this January or so, and they're going to represent us as an Elan University. I'm going to send an email. I'm waiting to approval from the CAA groups, and please check your emails and be ready for that. And what we did, also we transformed these great ideas from campus partners to Elan AI Toolbox. As you can see, we just put all those AI toolbox on our websites. Overall, we hope that this AI networks connect people and cross-pollinate some idea. Today, I'm very excited to host one of our recent faculty members. We are happy to welcome Dr. Alexis Goslen, Assistant Professor of Computer Science at Elan University. With a passion for education and innovation, Alexis worked on making AI concept accessible and engaging, especially for younger learners. Today, Dr. Goslen will walk us through strategies for building AI literacy in middle school students using game-based learning. Please join me. Welcome, Alexis.
Thank you very much. So, as Mustafa said, I'm Alex Goslen. I'm in the computer science department, and I actually started at Elan just in January. So I got my dissertation last year at NC State University, and Funnily enough, my research lab was the AI Institute for Engaged Learning group. Yeah, so a lot of what you'll see today is what they do. But yeah, I'm excited to get started and kind of show you some of the research that was completed as part of my dissertation and how we're gonna sort of transition it to here at Elon. So my research kind of falls in the middle of two areas. The area of artificial intelligence, where we take machine learning concepts, neural networks, natural language processing, and particularly large language models with the recent advancements with those, and apply them to education in several different areas. So we have game-based learning, informal learning, self-regulated learning, and particularly problem-solving skills. So how can AI enhance students' problem-solving skills while they're learning? And one direction that my research goes is trying to teach AI concepts to students. So taking educational techniques and applying them to challenging concepts for middle schoolers that might not have a lot of experience with technology. And then the other direction is developing adaptive support for students in real time using games. So that means developing machine learning models so that we can provide hints to students in real time that might help their problem solving, particularly in challenging environments like science problem solving. So I'm gonna start with this first one, and then we'll shift to the second one about halfway through. So game-based learning has a lot of benefits, particularly in problem solving, like I just said. So for young students, when they encounter challenging concepts like scientific reasoning, games can actually provide an informal way for them to engage with the material, and it's been shown to foster a lot of positive emotions for the students and actually drive some interest in the subjects that they might not have been interested in before. It's also great for collecting data. So each interaction in a game generates a trace log that we can use to inform our machine learning models on how they are learning, what their problem-solving processes are. So we can use that to then generate assistance for them. And I'm gonna shift just a little because the sun is right in my eyes. Okay. So the way that we can do this is by supporting self-regulated learning. And self-regulated learning is the cyclical process of identifying a task, setting a goal for that task, then creating a plan to achieve those goals, and then applying the strategies, seeing what worked, what didn't, and adapting it based on that. And this happens cyclically and is used as sort of a metacognitive tool. In scientific reasoning, this can be very challenging for middle schoolers, right? Like even thinking of what a goal might be for them to figure out an experiment is very difficult for them to do. So we have a challenge with getting them to engage in planning well or setting goals well. And what we found is that we can have learning environments that automatically adapt to assist those processes, which will then assist them in the whole learning process. So here's a motivating example that may or may not be from direct experience in a middle school classroom. So we have a student here. They are given a game that is challenging them to go through the scientific method reasoning steps to solve a mystery and identify a diagnosis. They interact with the environment and they may engage in planning activities, but they're doing it all in their mind, right? And when they first start the game, it's exciting, it's new, they're happy. As they navigate the game, it's going to get more challenging, right? They're getting more information, they have to synthesize that, apply their knowledge, and they begin to become frustrated because they are not able to navigate the environment as well. Eventually, they reach a peak where they cannot go any further in the game. They shut their laptop, they get bored, they go to sleep, right? And this is the case that we want to avoid. So in learning environments, we can actually foster their planning by providing tools to them to create goals and plans. And if we have some sort of machine learning, we can provide adaptive scaffolding to them. And what that means is now the student is engaging in metacognition, but they're able to formalize and externalize their goals and plans. And then that is fed into a system that will then, based on if they have achieved that goal or not, adapt and maybe provide hints on what to do next. And games that have fostered planning have shown to increase positive emotions for students, particularly in challenging learning environments. So in this work, we're defining a plan as a series of low-level actions that can be enacted in the gameplay. So that means moving, talking with the character, and I'll explain the game environment in just a second. But then what we can do is use large language models for plan generation. And what we mean by that is, given a set of gameplay actions, can we, in a target goal, can we generate a series of low-level actions that the student can enact in the game? And that could be provided to them as a hint, or potentially adapting the game to different strategies or task difficulty. So if we see that they're accomplishing their plans very quickly, we could actually maybe make the game harder for them, and they could learn more in the process. But we could also develop open learner models of their self-regulated learning to understand how well they are planning and adapting their strategies. So in my research, I built this framework, and what it looks like is we have a student interacting with a learning environment, and they have a planning tool integrated into the game. So what we can do is take textual representations of their plans and their gameplay and feed it into a large language model. And that's particularly helpful because in educational contexts, we usually don't have enough data to train robust models and provide hints that sound like a human might sound, right? Like it could be like, have you tried this? And then it repeats that hint over and over and over again, and the students get really frustrated. But with large language models, we have a new capability of providing natural language to the students. And so when we train our model, we provide the problem-solving sequences that students have, so the steps that they've taken in the game so far. We have their completed goals and a target goal. And so that's based on what they select in their planning tool. And the large language model will output a series of action sequences for that target goal. And that can be provided to students in real time, and then potentially that cycle happens over the whole gameplay. Where we implemented this was in a learning environment called Crystal Island. It was created back in 2011 or so. It's designed for 8th grade microbiology curricular content, and the narrative is that students are placed onto an island where there's a bunch of sick patients, and they have to explore the environment and identify the disease and the treatment plan for that disease to win the game. And it's been shown to have significant learning gains and high engagement. Particularly, it's used as sort of like an augment to what students learn in their typical science classrooms for 8th grade. The planning support tool that we embedded prompted students at most 5 times during gameplay, but they could access the tool at any time. And we had a total of 20 goals that they could select from and 55 actions. So there was a lot of things that they could choose from, which is why we might need to support it a bit. And here's just sort of an example interaction with the tool. So they could click on a goal, and it's block-based, which most of them are familiar with because of Scratch. And so they would select and drag and drop the goal that they want to achieve into the black box. Then they would select their actions, and they would actually nest inside of that goal. If they felt like they were done with that, or they didn't want to achieve that goal anymore, or they accomplished it, they could drag and drop it to the trash can icon, and it would actually ask them if they felt like they accomplished that goal or that plan, which was also important to us to understand if they think that they're achieving their goals. So we had a remote study back in 2020 with 144 middle school students that we used to try this plan generation framework. The students played over a 2-day time span asynchronously because it was during COVID. And they had no prior experience with Crystal Island. So they all played for about an hour and a half or so and either won the mystery or did not. And so to give you an idea of what this plan generation framework does is this is an overview of Crystal Island. Let's say the student started on the dock. They would first go to the infirmary. There they would talk to the camp nurse who would inform them of the task that they're trying to do to win the game. Then they would go to the laboratory and they would try to test some items for various diseases. But it was a negative test. That's what the X means. Then they would go to the dining hall and they would pick up milk. So they can pick up various items in the game and test them. So they'd pick up milk, then they'd go back to the lab, and then they would be prompted to plan. So based on that sequence of actions, what would the student choose to do next? What's their goal? So based on whatever goal they would select, our system would try to answer the question of what actions will they take to achieve that goal, right? So we're trying to get at developing plans, but also developing good plans. And the way that we would do this is we have a framework that we built. Like I said before, we take in textual representations of the student's gameplay, and then we also provide completed goals. So if a student put a plan in their planning tool and they completed all of the actions for that goal, we would count that as a completed goal. And then we would provide the target goal. Then we would have a label based on what students actually created during their gameplay for the same goal. And we would use that to train. We tried 2 different language models for this. There were 3 experiments total because we tried 3 different training techniques. But each of the models would output a sequence prediction for all of the goals and plans that students created in the game. And here's an example of what an actual student planning scenario looks like. So at the top, we have the goal, and then the little boxes are the plan, the actions that they selected. The green border means that that goal action pair actually mapped to a scientific reasoning step, which is trying to indicate if that is a good action for that goal. And so as you can see, this student opened their planning tool 5 times. They created one plan with 2 actions, but in their subsequent planning actions, they never changed their goal. And so to me, if I'm a teacher going in and evaluating their plans, that doesn't sound like a useful planning process, right? Over time, we would want them to update their goals. And so here, it's hard to tell exactly what the student's doing in their problem solving. So we would actually probably want to provide some sort of support, maybe at the halfway point, where we say, hey, are you trying to do something else? Or, maybe consider doing other actions that would help achieve this goal if you feel like you haven't achieved it yet. And so here are a few example plans that were generated from the large language models. The top picture is from the T5 model, and the bottom picture is from a GPT model. And what we found was that plans were largely similar to students, which has some pros and some cons. Student plans, like I just showed, weren't always optimal. And so, but there are no existing plan evaluation metrics in the literature. So the best we can do really right now is get as close to student plans. But it did show that LLMs are capable of generating solid plans for students. Every plan that was made was a valid plan that could be enacted in the game. There were some hallucinations. So if you look at this bottom right-hand corner, for test objects that spread disease, they generated a plan that said scan eggs. And that's actually a combination of several actions into one. But in a natural language setting, that actually might be better for students, right? Because if we say go to this location, pick up the egg, go back to this location, then scan it, right? It's easier just to say, how about you try to scan this? And that's what we found with GPT. A lot of the GPT models would summarize actions, but they were still enactable in the gameplay, which was cool. So there's kind of different use cases that we could have for each of these for adaptive support. Like if we want to provide a higher level strategy, GPT might be good for that. If we want to provide hints of saying something like, here's what another student might have created, then our first model might be better.
First model was T5?
Yeah. Yep. And so the things that we would want to consider moving on in the future with this work is that all the models that we tested generated plans with hallucinations, so we definitely want to go in and double check that what's being shown to the student is valid and can be done in the game, because that could lead to frustration if it's not. And it also requires considerable computational power to run LLMs locally. And so T5 would be good in that case because we could pre-train a model on a GPU machine and then embed it into the game. So all we have to do is ping that model that's already been trained, and we're not training it in real time. And especially when we're going into schools, even running the game on students' laptops is difficult, so we definitely don't want to add any computational power to that. Additionally, the GPT API that we used, I'm gonna have to shift again. Okay, perfect, sorry. Okay, the GPT API that we used is not free, so it was about 5 cents per ping to the API, which training over, I think it was something like 100 plans or so, it adds up. So if we wanted to apply this in real time, we would probably want a different model, especially in an educational context where resources are already limited. And additionally, there's data security risks with GPT as well. OpenAI says that when you use the API, it doesn't actually store that data. We can only take that at face value. And none of the data that was sent to this was identifiable in any way. It's not FERPA data at all. But still, we want to make sure that that's considered when we're choosing which models to use. And we definitely, depending on the educational setting, want to think about all of these things before we just put them into our games and let them run free. So I'll pause there, because that sort of closes this portion of my research. And are there any questions about this part? Sure.
So T5, as far as I remember, T5 model was decoder and encoder model.
Mm-hmm.
And then GPT model is only decoder models. It's not necessarily so big stuff, like decoder models or decoder and encoder model you use. Did you notice any differences in terms of the performance? You show us one of the performance example, T5 supervised learning, supervised model performs slightly better than the GPT 3.5. Is it often the case, or there's no differences in performance?
There's not many. I would say with T5, the main con that we saw with it was that it was generating really long plans because there wasn't a token limit. And so it would generate plans with like 260 actions, which there aren't even 260 actions in the tool. And so there's a lot of duplication, which adds more computational power when we're trying to process it back. So that was the biggest one. I would be interested to see how Llama performs, because that would probably be the best option for this case. But GPT had much shorter plans. And like I said, there's kind of use cases for both. Any other? Sure.
How did the students like it? What was their feedback?
They're vocal. So we didn't actually get a chance to show them any of the plans. The planning tool itself, they struggled with, just because unless they were prompted to do it, they wouldn't want to spend the time. They thought it was useless. And then especially as they get closer to solving the mystery, if you have something that pops up and says, I'm going to interrupt you and you need to do this thing, they get really frustrated by that. And so we toyed around with the idea of changing the prompting to be a bit more adaptive to that as well. So less prompting at the end for the plan, more at the beginning to kind of help with that. Mm-hmm.
Just for clarification,
Sure.
this is an off-the-shelf game that you guys were able to layer in the AI content?
So this game was actually created from the research lab. The research lab itself focuses on narrative games and building games that for educational content that we can then put AI into.
Okay, so the game was pre-built.
Yes, yeah, it was built about 10 years ago.
What was it like? What were the challenges? What did you have to do to then program in the AI portion?
So we had to go into middle school classrooms, have students play the game to then get their data, and then construct models to see what would work, and then put that into the system. So it's a very slow process, I would say, because we could only get into classrooms about once a semester, if that, and usually they're at the end of the year when students are less focused, and so it's a challenge. I'd say the biggest challenge is like getting the actual data to use. Mm-hmm. Sure.
In terms of the benefits of the prompts
Mm-hmm.
students receive, did that support engagement, their success in creating an optimal plan? Could you talk a little bit more about that?
So we only have data on incorporating the tool itself for students, and that showed a benefit in supporting their ability to solve the mystery. The learning gain was kind of negligible because it's more based on students' prior knowledge than anything else. But we didn't get a chance to actually have them work with a system that had the plans in real time. Yeah. Yeah. That would be cool. Yeah, I was thinking about maybe in one of the game courses, like a game design course, if students are interested in educational games, maybe seeing how they respond to it. Because I do think they would respond pretty similarly to middle schoolers in terms of the level of frustration with having to plan, or there's not a lot of data on how well students can plan and formulate goals and all of that, so it would be interesting for sure. I'll call you. Sounds good.
The game reminds me of Quest Atlantis by Sasha Barak. It's like the journey and the way that it's framed.
Yeah.
Is similar to the Quest Atlantis.
Yeah, and the original game was modified off of Half-Life, if you've ever heard of that. So it used to be like the sick people looked like zombies a little bit. Yeah. Okay, well, I can transition to the next one if there are no more questions. Perfect. So now we'll talk about some activities that we've done to promote AI education in middle school. So the context for this research is a project funded by NSF called AI Play. And the goal of the research is to bring AI concepts to students in rural areas that might not have a lot of technological experience, and kind of bridge that gap in knowledge, especially since the AI world is upon us. And we collaborated with both students and teachers with some of the game-based activities that we've created. And all of the activities are based on these 5 big ideas of AI, which is from the AI for K-12 website. But I'll talk about that in just a second. So what we did was we developed a summer camp curriculum where it's a 5-day camp, and on the first day, they learn perception, which is how computers perceive the world and make decisions based on that, based on sensor input and things. There's a robot relay game that I actually played in the AI course here too, and it's really fun where we blindfold one student and they have to navigate a maze. The second day is focused on representation and reasoning, so how an AI can represent the space of the world and then reason about that space. So in this day, we usually talk about facial recognition and things like that. On day 3, we dive into machine learning, so unsupervised learning, supervised learning, and reinforcement learning, and we have activities for all 3 that they play with. And on day 4, we focus on natural interaction, which is how we can make AI seem like a human, and primarily with natural language processing. So we talk a lot about Siri on that day. Each day, we embed ethics into the discussions because it's really important to make sure that they understand the models and how they're built and what the implications are or how they're being affected by AI. And on the last day, we typically have more fun activities or people coming in and talking about careers in AI and things like that. We usually show them the book Robot at NC State, if you've ever seen that. But it's more of a recap of the activities. So from this work, we've got 4 game-based learning activities that we've built. 3 are online, so they're virtual video games, and 1 is a board game. And the students interact with these during the days of the camp. But on the first day, we talk about pathfinding, which is what this bottom right-hand corner is showing, and it actually visualizes different graph search algorithms for them, and it races them, and it shows which one wins. And so by the end, they come away kind of understanding the pros and cons of different search algorithms and how they're used in video games. We also have, on the top right-hand corner, a reinforcement learning activity where there's a bird trying to get nectar from each flower, and they're actually racing a reinforcement learning trained bird. So they go into the environment, they have 60 seconds, and on the first level, the bird is only trained for about an hour. On the second level, it's trained for 5 hours, and then 10 for the last level. So it gets a lot more difficult as time goes on, and they get a lot more excited as the levels go too. We also have a natural language processing game where they actually go in and they modify a rule-based chatbot. So it's centered on concepts of AI in farming. They read a little bit about it, and then they write question and answers to then have a person in the game respond with those questions and answers. So they can directly see sort of how rule-based models work in a game. And then the last one is called Guess Whose Face. It's a board game, and there's 3 levels to it too, which is the green, blue, and the red. And the way that it works is there will be a drawer who sees the character and will put tracing paper over their character. And then the guesser will spin the board, and it'll land on something here. So let's say it lands on feature extraction +3. And what that means is the drawer will draw 3 dots around a facial feature, the way that a facial recognition model would work. And so by the end, they end up having a tracing paper that looks like this on the right-hand side, where they've outlined a face, and the guesser, just looking at the tracing paper, has to try to guess what character it is. And as you can see, it can actually be kind of tough because Taylor Swift and Tinkerbell kind of look the same in this photo, right? Just from their facial features. And so this one is really fun. We've deployed it in classrooms as well, and the students love this game. Another activity that we do is sentence generation with NLP, and this one's fun because we put it in the context of SpongeBob. And what we have them do is we give them the steps of how a large language model might work, or just a language model in general, and we say, we need to train a model on a corpus, which is a body of text. Then we need to identify a set of words to create a sentence. Then we need to calculate the probability of the next word based on the previous word, or the words in the set, and then we add in that word. And then this process repeats over and over again. And so what we do is we say, let's try an example. Here's a corpus, and it's an actual episode of SpongeBob SquarePants. And we say, here's a sentence. So SpongeBob goes through crazy adventures with his best friend, blank. And we typically ask the students, so I'll ask you, what would be filled in this blank here? Patrick, why? Yeah, because in the language model, best friend Patrick are all next to each other, right? Like we wouldn't say best friend Sandy because Sandy isn't there. Yeah? And so this gives them a nice way to kind of visualize it, and then we actually flip it and put the goal on them to generate a sentence. And so what we'll do is we'll give them this corpus, and we'll divide into groups, and we'll say, choose a person in the team to start. They pick a word based on the corpus of what most likely, like to start with, we would probably start with a word from a first word in the sentence, right? And then they have to pass the paper to the person next to them. And then once they build a sentence, we have typically an instructor annotate the data. So it's reinforcing that human in the loop concept of someone will need to check to make sure that this sentence actually grammatically makes sense. And we have a winner based on who generates the best sentence. And you get some funny sentences with this. So we do this with just this corpus, then we expand the corpus to the human language, which is where the creativity really comes in. And then finally, we'll say, what if our syntax changes? What if our corpus becomes pirate speech? And so the whole sentence structure would change, right? If our language model has verbs come before the noun, that kind of thing, or you just say I all the time. And so it helps them sort of see how different contexts impact the language models, and they get direct experience with that. So we implemented these activities in a summer camp in 2023 with about 10 students at a Boys and Girls Club out in Greenville, North Carolina. And then in that fall, we actually had a teacher professional development session with local teachers in that area too. And the idea was that we would give them these materials, they would engage with it, and then take it to their classrooms to see if it can be integrated into a formal classroom setting. And then in the winter, we actually had some of those teachers implement particularly the Guess Whose Face game, which is what this picture is here. And that was largely successful. And then we had another summer camp in the summer of 2024 where we had 24 students. And that was for students local in the Raleigh area. And then we held a teacher PD for 6 non-CS teachers in that fall. And what we found was that after each implementation, we refined the activities based on feedback. There were some bugs in the games, of course, but also in the first implementation, our NLP game didn't have a farming context, and what we learned was that a lot of students in rural areas are actually very familiar with farming, so we said, maybe they'll be more engaged if we make it more about farming and stuff like that, and so that's what we did in the 2024 camp, and that seemed to help. And we took surveys after each day of the camp as well, and those surveys suggested that there was a lot of increased engagement in the AI concepts, and they walked away with a lot more understanding of AI than when they started the camp. So we'll call that a success. And then we also found that allowing students to modify the AI behaviors really helped foster sort of an inquiry-driven approach to AI, so it's fostering that interest and helping them problem solve through those challenging concepts, and that seemed to drive engagement. So, yeah. And then the future work for this is we want to further refine the activities. I'm integrating a lot of these activities into the AI course this fall here at Elon to see how undergraduate students respond to it. So far, it's been good. But typically, the AI course has a lot more technical information, so combining these two things is an interesting challenge. And then we also want to, what?
How much do our students know about farming?
That's a good question, yeah, exactly. Yeah, and then we want to provide additional training materials for middle school teachers to help implement these and continue AI literacy in these areas. So, yeah. Are there any questions about this?
I have just comment, very nice.
Sure.
Oh. Really nice research. And most likely you heard the federal state just in last year, 2024, April 23rd, they said we are just encouraging AI literacy for K-12 level.
Mm-hmm.
And there's a lot of opportunities coming up, a lot of grant possibilities. And
Yeah.
September 3rd, 2025, Texas State Governor also declared an executive order post, and in that executive order, K-12 level AI literacy was one of the priorities.
Oh, cool. Yeah.
You may have opportunities to get some grant or further research stuff.
Yeah, absolutely.
Have you ever explored all those?
As a grad student, yes, I've helped write some of them or contribute to this one is still active, I think, for another year or so, the AI Play grant. And yeah, I've tried to continue the summer camp to see if we can get more data and stuff like that. So
We have some summer camp activities here as well.
yeah.
Are you planning to do something here?
Mm-hmm.
Summer group or?
She's gonna support some new summer camps, so she's gonna do a week-long AI camp for the university.
Mm-hmm.
Perfect.
Yeah, I think so.
And
Yeah.
now you can get data.
Right. Yeah.
Yeah, students.
Yeah. Absolutely. Yeah.
I have a question. In
Sure.
terms of the activities that you had for literacy, right?
Mm-hmm.
Was there any differentiation in terms of what was more impactful in terms of the activities? I know that there was one around the TLS phase that was students like it, but
Mm-hmm.
in terms of impact, understanding the major concepts of AI literacy, what
Mm-hmm.
it means for them, what it means for them as students, was there any differentiation that you found?
So, just based on my observation, students responded a lot more to paper-based or non-computer activities. It seemed like they were able to focus more when laptops were shut. Once we open our laptops, other games magically appear on their machines. But the paper activities really seemed to give them hands-on experience. Like we have an activity that is a candy classifier, so we put candy on the table and then they have to identify features of different types of candy and things like that, and that seems to drive a bit more interest than just trying to code on a laptop or something like that. Yeah, anything else? Awesome. Well, thank you. And these are the collaborators. And then here's some publications on the work as well if you're interested in more. But
Thank you.
yeah, thank you.